Consider the reaction of the combustion of hydrogen, where two hydrogen molecules react with a molecule of oxygen gas to produce two molecules of water. Now, if you were to start with a container which had two molecules or moles of hydrogen gas and two molecules or moles of oxygen gas, what would you get after the reaction had gone as far as it might, after it had gone to completion? Okay, so what would be left over in that pot? Well, you know that two hydrogens combine with one oxygen. So perhaps these 2 moles of hydrogen might react with 1 mole of oxygen. And when that occurs, when 2 moles of hydrogen react with 1 mole of oxygen, that forms 2 moles of water. And so these 2 moles of water will be formed. But you can see that some oxygen is unreacted. This oxygen which was unreacted, because we had excess of it, we had more than we needed to react with all our hydrogen, that oxygen was our excess reactant. That is, it's the reactant which will have some left over after the reaction is reached completion. And that hydrogen, which ultimately was all used up, that is what limited the amount of our product that we could get. We might have been able to form more hydrogen, water, except that we ran out of hydrogen. Hydrogen here is the limiting reactant. You can see that it should be used up, ultimately, if the reaction has gone to completion. This reactant determines the theoretical yield. It determines how much product should be formed if the reactant goes to completion to use up all of the limiting reactant. That theoretical yield is how much product should be formed if the reaction goes to completion and all of your limiting reactant is consumed. So we can demonstrate this reaction by using some numbers. It's a nice way actually to demonstrate how we can go from amounts of reactants into products to determine the limiting reactant, excess reactant, and theoretical yield. So the general kind of model that you'll be following is, in order to determine the theoretical yield, you need to convert from amounts of 2 different reactants into amounts of one product. When you convert from the amounts of these reactants into product, the smaller amount of product is going to be your theoretical yield. And the reactant which was connected to that theoretical yield, the reactant from which the theoretical yield was determined, the reactant that determines the theoretical yield, is the limiting reactant. If that is the limiting reactant, then the other reactant or reactants must be excess reactants. And so consider where we have 2 moles of hydrogen reacting with 2 moles of oxygen. What is the limiting reactant, excess reactant, and what is the theoretical yield in the formation of water? So start out from the amounts of both reactants and convert into amounts of products. In this simple case, let's just go into moles of products. So convert from your moles of hydrogen or oxygen into moles of water using mole-mole ratios, which come from those coefficients in the balanced chemical equation. So you get 2 moles of water formed if all of our hydrogen is consumed. And you get 4 moles of water if all of our oxygen is consumed. Now we saw ultimately that our theoretical yield in this model, which was just like our mathematical one, showed that only 2 moles of water should actually be formed, not 4. That smaller amount of product is our theoretical yield. 2 moles of water is our theoretical yield. So our limiting reactant is the reactant from which we calculated that theoretical yield. It's hydrogen. And you don't need to say the amount per se, just what compound it is, or element. And so that other element, oxygen, must be our excess reactant. Now what if I asked you to go into limiting reactant, excess reactant, or theoretical yield in grams of some product, and I gave you grams of your reactants? Then, just like before, you need to go from amounts of your reactants into amounts of products. Find a smaller amount of products, that's your theoretical yield. And so, in order to go from grams of one thing to grams of another, or in order to convert between two different types of compounds, you have to do that using the mole-mole ratio. You need to go to the land of the mole. So convert your grams of hydrogen into moles of hydrogen, then into moles of water, into grams of water. And so that's all written out here. So we can see that our smaller amount of product, 36.04 grams of water instead of 72.08. Our smaller amount of product, that must be our theoretical yield. And then our limiting reactant was that hydrogen, and then our excess reactant was the other reactant, oxygen. Now what if I asked you to determine the percent yield of that reaction if you only collected 14.3 grams of water? Now if you reacted 4.04 grams of hydrogen with 64.00 grams of oxygen, you should have gotten 36.04 grams of water. But you actually only get 14.3 grams of water. Now, if this were a test, and you got 14 points out of 36, what percentage grade would you get on that test? You would get about a 39 or 40%. Similarly here, you want to put your actual yield, the number of grams of water that you actually collect, over how many grams of water you should have collected, your theoretical yield, multiply by 100%, and that is your percent yield. You got 39.7% yield. Thanks for watching, guys.